Hello, everybody. So welcome to USC Architecture Research Seminar again. So actually, I believe that many of us may be tired and stressed this pandemic season. So I always hope you stay healthy and also productive this semester. So yeah, today we have Dr. Erica Cochran Hamin. So she as a fifth speaker this semester. So the Erica Cochran. So she's an architecture designer and assistant professor at Carnegie Mellon University, where she served as a co-director of the Center for Building Performance and Diagnostics. And she is also track chair of the director of a professional and practice program and the architecture, engineering, and construction management, so AECM, PhD program at CMU. So her architecture experience include more than the 50 educational and media and broadcast and residential and community and transportation facilities. So she holds multiple honors, including the Pittsburgh Courier Woman of Excellence Award and AIA Award for diversity recognition for the U Dream program at CMU. So Erica holds a Bachelor of Architecture from Virginia Tech, and MS in Sustainable Design, and PhD in Building Performance and Diagnostics from CMU. So she led research project focused on the improving indoor environmental quality and energy efficiency and energy policy. She serves on the board of directors for the Green Building Alliance, and she is a trustee for the Phipps Conservatory and Botanical Garden. Okay, so please join me to welcome Dr. Cochran.
Thank you so much, Junho, and it's a pleasure to be here.
Okay.
I'm going to now, let's see, slideshow. Okay, can you see, do you see
Yes.
Okay, good. And making sure the presentation notes are on one side and your stuff is on the other. All right,
yes.
This is great.
Yeah.
So
yeah, great.
Thank you. I'm so excited to be here. And you know, I love that you're doing a lot of things remotely. And so, you know, I'm gonna just talk about like these intersections of indoor environmental quality, energy and data analytics, then taking that data analytics and looking at how it can inform policy, and then key takeaways, and then have some time for discussion. And so, Junho, we need to be finished by 4, right? You're on mute. So 4, yeah, you're on mute. So I'm guessing 4 is okay. You're on mute.
So 4 p.m. Yes. So
okay.
It means that 1 p.m. over here. Yes.
Okay. Oh, that's right. After I'm on the East Coast, so I have to subtract
right.
3 hours.
So
I did not mean I was keeping you guys for 4 hours.
Yes. So yeah, after your talk, and maybe some about the 40 or 50 minutes of your talk, so we will usually have a Q&A session for 10 minutes. So okay. So
Okay.
if it's slightly over time, it's okay. But some of our attendees may leave for some another schedule or class. So yeah. Okay. Great.
All right. Great. So, you know, some things I'm going to be looking at the time. And so I may skip over a couple of things because I want to make sure we have time for Q&A. So, you know, just as a context, these are just different types of healthy and sustainable environments and places to live, to work, to breathe. You know, these look like exciting places where I would want to go to school or where I would want to live. And so, you know, so there's a lot of research, or what I do is focus on how can we make sure we have more of these type of environments. And so it's about what's that connection and why is that connection between these 3 things so important? So if we look at indoor environmental quality, those types of things and those metrics are going to influence, you know, our health and productivity. It's going to help us even look for clues in how energy might be used. And also occupant satisfaction. Do we feel comfortable? Are we happy? Are we mad or angry about our space? And if we look at energy and data analytics, it can help us prioritize decision-making so that we're not just making decisions without any kind of backup data. It can inspire new technology because maybe there's not a solution to the problems we have, so we can find something new. and then also helps to provide data for benchmarking and transparency initiatives. And these two initiatives should lead to improved policy and regulations. So looking at how we can use these to make new strategies for energy efficiency, how we can use these to set new goals so that we can encourage equity and promote sustainability in our environments. So why is that important? Well, because, you know, just to talk about sort of like where we're living now, we're living in this situation where new products are now being sold, right? So now we're in social isolation. Kids still want to have story time together, but how do you do story time? And now new things are on the market, like plexis and masks and having colorful and creative masks. So we're trying to find new ways to still have an indoor environment, still have that connection with people, but keep safe. So then you look at other types of environments. You know, we talk about natural ventilation. Well, these guys on the left have natural ventilation, but I don't think that they would necessarily, I don't think this is somewhere where we would want to live. You know, there's a lot of places that are having issues because of climate change where increased flooding is happening. We've got buildings that are deteriorating. We have people living in various types of conditions. And so when you look at all of these types of conditions that people are living in, excuse me for the interruptions, they could happen within the next 50 minutes back and forth. So, you know, we say the other thing that happens, and it's happening all over the world, is that you have protests, right? So the protests are happening because of police brutality, but the protests are also happening because of inequalities. The ones in the center are from the sister of one of my PhD students in Nigeria. And, you know, they're talking about this, do you go to school or do you try to have equality? And so as you know, one of the reasons why a lot of these protests and things are happening is the police violence, of course, which is wrong. But then from the architecture side of it, there are people who are living in various types of situations where their indoor environmental quality is not promoting something that's healthy and sustainable. And it's causing people to, especially people of certain demographics, to die at faster rates from COVID, and to really see a lot of the inequities and want to do something so that they can breathe and have fresh air. So let's first talk about indoor environmental quality. A lot of my research is focused on schools. And one of the reasons for that, aside from loving children, is that when you look at kids, they're smaller, they're closer to the ground, they have smaller lungs, all of the types of things that would happen to adults, children are more susceptible to them. And so if we look at some urban schools, we see, and these are, I think most of these are actual pictures that I took before I became an academic and I worked as an architectural designer in New York City. And some of these are from different areas, but you can see issues of various issues, lack of daylighting. We can see rodent infestation. We can see water infiltration coming through the walls, through the roofs, up the toilets and down the stairs. And so you tie all of these things in and say, well, what does that mean? Well, you know, these things have an impact on teacher turnover, as well as missed days of school from asthma, and then proficiency in test scores in math, science, social studies, and English. And then how does this tie in with electricity and energy? Well, if you think about a building that's lost its R value because it's falling apart, or you think about windows that are not opening properly, or we're not using daylight, we're literally wasting a ton of energy, and we're spending more money on energy than we do textbooks and computers. One funny story that I like to share is that, you know, we always talk about having thermostats in rooms and zoning spaces differently so that we can control the temperature in a space. Sorry. But this one school I went to, they had one zone for the school. And so what the custodial engineer just turned the temperature as high as it could get so that everyone was warm. And to regulate your temperature, you had to just open your window a lot or a little bit. And that's how you controlled your temperature. So literally they were throwing heat out the window. And there's got to be better solutions than that so that we can save money. we save money, but it's also about helping lives, improving asthma rates, and then thinking about the toxins. Kids, again, they're closer to the ground, but when you think about all the different plastics, the things we use to clean buildings, the lack of ventilation, classrooms that are in the basement, rooms that don't have windows or windows that are sealed and don't open, all of these things have an impact on health and productivity. So, I always say the picture on the left is how I would like to work. I'm in Pittsburgh, so we don't get this kind of weather only half the year. You guys are in California, so this is your all year round. But this is how we want to live, right? And so what we want to do is say, how can we bring the outside inside, so that even when we're inside, we're still having fun, we're enjoying ourselves, things are great, but things have changed. Now we're in masks. Our inside office is now our home, and we're all living on Zoom. So what is our new norm? And is there a new norm, or are we going back? Personally, I don't think we're going back. So, but still the question is, whatever your work environment is, whatever your home environment is, whatever the condition, whether it's pandemic or non-pandemic, how can we make these places wonderful places to be comfortable? So I am a person that likes interactive types things. And so I'm just going to ask everyone if you can use your thumbs up, thumbs down. Has anyone ever been in an office or a classroom where this is how you felt? I see some thumbs up. Yeah. And I've gone to conferences, and you sit there in a conference and I'm like, oh my gosh, why is it so cold in here? And I feel like I would love to have a candle to try to stay warm. And so what can we do to not feel like this when we're at our desk? 3 easy steps is to first measure. So that's what we want to do. We want to go in and measure. Then we want to evaluate and assess the findings. Let's see what's happening. And then we want to make improvements and make recommendations. And also, sometimes that means creating new technologies. And so that's what I'm going to talk about. And I'm going to just try to say, excuse me, 1 minute. So this is exciting. And this is part of my new indoor environment, acoustics. And so if we're talking about acoustics, that's one of our 5 measurable variables for how we measure indoor environmental quality. This is work Junho knows all about this. We've been making some advancements with the NEAT cart. We're actually building a NEAT robot right now. It's being built in pieces across different PhDs' houses while we're in the pandemic. But if we look at these different assessments for how we measure, we want to think about the visual quality, acoustics, spatial, thermal, and air. But then also when it comes to children, we also have to make some tweaks for what we would do with adults, because kids are at different heights. And so it becomes also very important for the breathing zone to be able to change. And because, a 5-year-old is going to be at a different height than, a 12-year-old. So if you're interested in this more, there's my PhD students and I published a paper where we indicate protocols for how to measure school environments. So I want to talk about some work that we've been doing with Pittsburgh Public Schools to help improve their indoor environmental quality. And the idea is to do qualitative and quantitative assessments, but also for the CMU students, college students, to work with elementary, middle, and high school students. Yes. Okay, and so in this photograph, one of the things that you can see is these are college students and high school students working together to do an assessment. Okay. And so what we're doing is they're measuring everything together and looking to identify the qualitative, which is going to be doing surveys and asking people how they feel, but then also measuring the quantitative. So that's measuring what the CO2 levels are, what the temperature levels are. But it's also an exciting way to get students excited about STEM. and get, 8-year-olds to say being an engineer, being an architect is cool because I get to learn by doing. And for high school students, they work on the reports and the assessments for their schools with the college students. And then after the report is issued, they help to implement some of these ideas in their schools. So it gives them a sense of ownership for their building. Why are some of these things important? In regards to looking at insulation, it can help you identify where you might be missing thermal breaks in windows. You can find holes and gaps in the building where not only can water seep through, but it also could be a place for rodents and other pests to be able to come into your building. And so using a thermographic camera is a way to really be able to do detective work to identify various things within your building. So why do we do this?
Audio and video have dropped out.
Just a second. So let me contact her by phone. Oh yes, yeah. Welcome
So
back.
sorry
Okay.
about that.
Yeah,
This is the
yeah.
other
Just go ahead.
problem let me go back to where we were. Fast forward.
Okay.
All right. So
Yeah. Please share your screen.
okay. Oh, thank
Yeah.
you.
Yeah.
Let me exit here. I'm fast forwarding. Sorry about that. And go here and share screen to share. Can you see this? It should be popping in.
Yeah. Yes, we can see that. Yeah. Great.
Oh, I might be sharing. Do you
Oh no.
see
So,
this?
yeah, the correct screen. Yes. Without
You see-
no. Yeah.
without
Without
notes.
script. Yes.
Okay. Great. Wonderful. Thank you.
Okay. Yeah. Please
Okay.
go ahead.
Okay, so are you all seeing temperature and humidity measurements?
Yes.
Yeah.
Okay, great.
Yes.
Thank you.
Yes.
Sorry about that. All right, so one of the things that we know is that what would be our thermal comfort zone, but we can see that a lot of classrooms are outside the comfort zone. They're not in comfort. I've gone into classrooms in schools where the temperatures range as low as like 60 degrees, and then some classrooms where they're 80 something degrees, and humidity that's outside the rooms. Carbon dioxide is another important issue because we know that we should, to have that optimal carbon dioxide, I like to keep it at like, less than 800, but at least no more than 1200. But we're seeing levels that are approaching close to 5,000. And once you get to that sort of those types of numbers, then you start to lead to headaches and dizziness and nausea and other types of serious symptoms. And remember, these numbers are in classrooms with 8-year-olds. And so, as we talk about the connection between the indoor environment, it's very important to, that's why I said the first thing to do is to measure and see what our conditions are. Other aspects that we should look at as we're designing buildings, since we're architects and designers, is the shape of the building. The shape of the building can have an impact on acoustics. It can impact the ability to have learning clusters, natural ventilation opportunities, as well as opportunities for daylighting to come through. And it also can help with security. And so buildings of a certain shape have a statistical correlation with attendance rates, as well as window to wall ratios having an impact on English and math scores, as well as attendance rates. And so, from here, you can see that optimal is the 20 and 30 something percent window to wall ratio. Once you start getting to the 40s and 50s, it's good, but you then have to have the right type of shading devices to be able to control for glare. And of course, one of the worst things to do is to have classrooms without windows because those tend to really have depressed English and math scores. Looking at HVAC, I showed the temperatures that we're finding in some of the schools, but then how does that relate to test scores or absenteeism or things of that nature? The condition of the heaters are related to attendance rates, and they can also affect productivity. But another thing is also thermostats. A lot of classrooms don't have thermostats in them to be able to zone the spaces separately. But one of the worst things to do than to not have a thermostat is to put one in there and then put a key on it so the teachers can't do anything about it, because that's one way to really have the lowest teacher dissatisfaction, keep the teachers unhappy in their classrooms. So when we see these sorts of problems, you know, what can we do? So one of the things is to make recommendations using current technology, but it's also fun to say, what can we do and create new technology? So I just want to talk a little bit about some new technology that we worked on and why we did it. So the idea was to say, we understand that there are all these differences in ventilation and all these differences in thermal desires. And even if we were to try to keep everyone between 68 and 72 degrees, men and women want different things, old and young want different things, people from different countries and continents want different things. So the question is, how can you make everyone comfortable if you have all these different demographics in an open plan office? So one of the things that we worked on is to have an individual task conditioning system, but also be able to do it without the person having to wear anything. So the idea with this is that at each person's desk, they had a new sensor that sat there next to their monitor that read your face. And from the face, what it was doing was looking to see if you were hot or cold, and then doing crowdsourcing to identify, you know what, 80% of the people in the building or in this office are hot. So this way your HVAC system recognizes that the majority are hot, change the temperature. But if only one person is hot, then their individual fan would turn on. And of course, if you were unhappy with it, you also had the opportunity to override what our algorithm was recommending for you. So we did this as a couple of tests. We're trying to black out the faces of the students. Most of our test subjects were all students. So as you all know, that's who we use for experiments is your fellow grad students to check. And then did things on a 7-point thermal scale to identify whether they were hot or cold, so that the system could learn from the activities they were doing. And so pretty much the more you interacted with it, so if the fan turned on or the temperature changed, the more you said whether you liked it or didn't, our algorithm learned what you desired more and more to get to the point where it could consistently recommend the right thing for you as soon as you sat down and it knew what temperatures you liked. So, how does this help? We also did a number of, I'm going to just like breeze through some of the other things, but we did a number of modeling and CFD studies to be able to look at air distribution and how it was going to affect the room, so that we could then extrapolate the data from the different tech subjects to see how it would affect a larger building. And what we did is identify that by having just people be able to identify what comfort they wanted and then adjust it for anyone that was uncomfortable, we saw an average HVAC savings of almost 10%. The other thing was that at least 80% of the people were very happy. And then we were able to, with very good accuracy, predict what people wanted for men and women. We had a slightly easier time predicting what men wanted than the women. So that was also another interesting thing. But we haven't dove deeper to find out why we could predict a little easier for men than women. So, I talked about IQ. So I want to, start to transition to looking at how all of those things affect energy and why that's important. So these are things that, a lot of us already know, how much energy buildings are using, electricity, that a lot of greenhouse gases. When you look at the breakdown, electricity production being at 27%, most of that is for buildings, and then commercial. So you can really see that buildings have a very big impact on carbon emissions, which we know, of course, has an impact on our health and our environment. So again, what we want to do is be able to try to look at what the energy consumption is and be able to say, how can we lower our heating, lower our cooling, lower our lighting, but again, always keep people comfortable. So our end goal, I always say, what's our end goal? Our end goal is to know how things are going, measure the energy, make a recommendation. But in order to do that, you have to do a building audit. In order to do that, you need to be able to first benchmark things. But there's another problem that's even before all of those things, which is a huge hurdle, which is getting the data. And so while this may sound simple, it's actually one of the largest problems for doing benchmarking is actually getting a hold of the data, getting access to the data so that you can then figure out what types of recommendations you should make for the building. So there was a project that was called the Energy Data Accelerator. And the purpose of this project, it was started under, as part of President Obama's Climate Action Plan. And yes, we did finish it right before he left office, so that was wonderful. And the goal was to make it so that 20% of commercial buildings in America, that we could get access to their whole building energy data. A number of cities participated, quite a bit out where you guys are in California participated in this program. And the goal was for the mayor's offices and the utilities to work together to figure out how to have whole building data access, and then cities that figured it out to share best practices with other cities so that we could have greater success. In the end of this work, which went on for a number of years, we were able to have quite a bit of success. And one of the biggest things that we were able to do within a few years is get 2.6 million commercial customers saying that they were going to have access to whole building energy data. And so this was having the utilities adjust how the meters were going, the types of meters that they would have in buildings, and how the meters would be read, and the types of software that would be available for customers, and doing that for 2.6 million customers across the country. So, very excited about that. So, okay, now we have the data. We've talked to the utility companies, we figured all that out. Now what do we do with all this data? What happens next? So that becomes the next question is, what do you do with all this data? You just ask the utility companies for data, what do you do with it? So let's talk about some of the things that can be done with data and why we want to use it. So my dream would be, imagine if all buildings had signs on them that you could tell how much energy they use, what your electricity bill would be, what your gas bill would be. It told you about your environmental quality score and told you your carbon dioxide levels were going to be like this. You had low toxins for health and all these wonderful, great things and great lighting. But unfortunately, we don't have signs on buildings. So we just have to hope for the best, right? But there are options and there are policies that can help us get a little closer to this type of transparency. One thing popular in Europe is that they do score buildings on a scale. And so this is an example on this kind of A through G, where you can see you cannot buy a building or rent a building without knowing what's happening in your building. So this way, you're not buying like with a car, you're not buying a lemon. You have some sort of understanding. And so that's where we want to start to be able to benchmark where our buildings are, and then have transparency, make it available to people to see what's happening. Looking at the West Coast, one example of a place that is doing a phenomenal job is in Seattle, Washington, where you can see they've had benchmarking ordinances on their books for quite some time. And it's allowed them to be able to identify which of their buildings need the most help, target those buildings, and then see improvements and be able to have money back. And if you think about just doing this for all the city-owned property, it really provides a lot of extra money for the city budget. Carnegie Mellon has worked with the city of Washington, D.C. to provide some portfolio analysis for them, for their buildings. This is done also normalizing for heating and cooling degree days. And again, with the idea to be able for districts to see how energy is being used. And so, you know, this is something I'm just gonna briefly talk about, because one of the other things that's important when talking about benchmarking data is to be able to be strategic and help cities understand the importance of benchmarking data, because sometimes you don't want to go through the work of that ordinance if you're not going to see a benefit from it. And so this is research that was looking into over 900 buildings in the city of Philadelphia and analyzing their existing energy, annual energy, monthly energy, as well as 15-minute interval data, and being able to make predictions to look for what should different types of recommendations be. The other goal of this research was to identify what type of recommendations you could make if the only thing you had was annual, and then what type of recommendations you could make with monthly, and then also looking to see what type of information you need for interval. And this is really important because some people don't have access to interval data. So if you just have monthly, can you figure anything out? What can you do to help people be able to make recommendations and help cities make strategic planning decision making? So in order to do that, you know, the first step is to just check out the Energy Star score. Look to see which properties have those high scores, which ones have low scores. Check out your EUI per square foot, how much money people are spending. We really like to do lean analysis, which is a nice way to evaluate buildings when you only have like that monthly data, but you don't have all of the 15-minute interval data. And what you can do from the lean analysis is identify through the yellow what that base energy use is, and then be able to parse out how much is used for heating, excuse me, how much is used for cooling, and when your peak times happen. What's exciting about this type of analysis is if you can imagine you have a portfolio of 100 or 200 buildings, this can help you just see certain key things. For example, are you heating and cooling your building at the same time? That's something we've seen. We've seen buildings where they have the heating and cooling on at the same time. It helps you to be able to also graphically just be able to identify which of your buildings have higher seasonal heating, even if they're still in the same type of climate zone. So again, helping you to be able to prioritize your decision making. So step 3 was with this project, we did a lot of work with looking at building attributes. There's a lot you can find out about a building from just being on the outside without even going in. And then be able to make determinations and make recommendations. Simple things like providing setbacks for buildings. So in the end, one of the things which was key, and this was something that was important for cities, is to help them identify what type of data you need in order to be able to figure what certain things out. For example, we were able to identify that the shape of the building, if we knew the shape of the building, we could make certain types of design recommendations with interval and monthly data. However, certain building things you could do if all you knew was annual data, but it helped us identify what interval of data was needed in order for us to be able to make recommendations. So this helps us how? If you think about, in the future, you're out working and you get a client who says, all I have is monthly data. Well, then if you have monthly data, I can already figure out these types of recommendations for you without even having to do interval data. Or it also can help you identify, you know what, I can't figure that out unless you can get me that 15-minute interval data. Okay, so we know what we can do with benchmarking data. We know why it's important. So what happens when you first get that data? The city of Pittsburgh's first benchmarking report came out in 2017. It came out in 2019 for 2017 data. The 2018 report is still being written, so it has not been released yet. So this is the most recent report. So this was huge for the city of Pittsburgh. when we finally got a benchmarking and transparency project to be able to know what's going on. And so from it, we could see how many buildings the city owned, what type of energy was being used, all of that sorts of thing. What we do, so the city of Pittsburgh is really pushing to improve our energy use. Why? Well, one of the reasons, and Junho lived here a number of years ago, is we have a huge energy burden in the city of Pittsburgh. We are ranked 7th in terms of worst places in the country for energy burden. And so what that means is that if you live in Pittsburgh, you're spending a higher percentage of your income on heating and cooling and putting the lights on in your building compared to people almost, most other places in America. And it's not just because it's cold and wet and snows here, because we're doing worse than even colder places. So it's really about our building stock. So one of the things that the benchmarking report has allowed us to do is to be able to identify, at starting with the city building, with the city as a leader, which buildings were using the worst energy. And so what our grad students have been doing is doing the analysis for the city to help the city of Pittsburgh prioritize which buildings to work on. And then the city has also decided to take up an initiative to make all of their city buildings zero energy, which is really exciting. And if you think about it, that's going to save citizens a lot of money, so that all the money the city was using to pay electricity bills and heating bills can now be moved into other programs to help the community. So we recommended to the city that they start with vital service buildings. The city took us up on that recommendation, and they are working right now to make the firehouses in the city of Pittsburgh zero energy. So they're going to start with police stations and fire stations. We're now analyzing the rec centers for them. And so if, I'll let you know next year which rec centers we decide that we should work on first. So our process is done through a lot of utility and weather data analysis, a lot of regression analysis, and different types of modeling so that we can identify which buildings the city should work on first, and just help them prioritize which contracts they should give out to architects and contractors to begin with. We've also been helping them identify which are the best buildings for using of PV and the types of carbon dioxide emissions that would be reduced for the areas and the different neighborhoods. So what does this mean for the city? Basically, what we're showing them is that by starting on the vital service buildings and using some of the recommendations that we're providing them, we could reduce operational carbon dioxide emissions by 40%, utility costs by over 60%, or nearly $250,000 annually in electricity and gas bills for just 52 buildings. And so when you think about the different types of services, and remember those earlier images of what the schools look like, how is the city going to find money to fix these other types of infrastructure? Well, it's money that's being spent on the utility. So it's not even trying to raise taxes on people. It's saying we keep things the way they are, but we're going to use your tax dollars instead of paying electricity bills, but we're going to use them to invest back in the community so that you can have better highways, better schools, and better buildings and healthier places. We've also recommended that by the addition of solar, we could increase the annual savings from $250,000 to over $700,000 annually. So again, I always just bring this back to the people, because to me, I do all of this not just because of the numbers, but because of people. Because every time we're talking about a reduction in kilowatt hour, every time I'm talking about, well, I can save you $700,000 annually, every time I say we can reduce your carbon emissions or take toxins out of the air, it's really about helping people. It's about helping people no matter what your demographic of race or income or socioeconomic status. It's about helping everyone so that you're comfortable. And it's also a life safety issue. So if you look at, for example, the photograph on the right, and you can see a situation where the family is not comfortable. They don't have proper heating. And so what are they doing? The plug load is now going to get high. They're using a heater that we all know is not good. If that thing tipped over, that's a fire hazard right there. And it's just providing a localized heat source. And so these are all things, you know, every time we make a decision, it helps the wealthy and it helps the low income. It helps people across all spectrums of life. And you know, that's really why I'm doing what I'm doing, because we want to make sure that energy burdens don't happen. And so that everyone has an equal opportunity to live in a place that's comfortable and go to school in a place that's comfortable. So I've been talking about energy burden. So just to show why it's so important for what I'm doing out here in Pittsburgh, you can see again, especially for people who live in a low income household, Pittsburgh is one of the worst in the country. And then for African-American homeowners, they are second only to Memphis, Tennessee, in terms of having living in energy poverty, where a significant percentage of your income is going to your light bill and your gas bill, as opposed to living and buying food and things that you might need. This is also an important thing because you can see there's definitely disparities related to race. And so that's another thing. That's another issue of why I'm doing what I'm doing, because there's differences across race as well as across socioeconomic status. And then in particular, Pittsburgh resides within Allegheny County. And some of the other work that we're doing, aside from benchmarking ordinances and trying to make all of our buildings, our city buildings, at least zero energy, is that Pittsburgh has one of the largest 2030 districts in the country. And we're pushing for reductions, not only in energy, but in water, as well as greenhouse gases. And so, you know, great, I finished with 10 minutes to spare because I wanted to make sure we had time for a conversation. One of the things that is important for me is to always ask everyone to say, I don't have all the answers. I know there's a lot of challenges out there. And how can we look and work together so that we can identify the challenges, talk about them openly, and then think about how we can come up with new creative solutions. And so, you know, if we were to say, what are some of the 5 key takeaways? Data is fun. I think data is super exciting. Data can help us prioritize our decisions so that we can have better building performance. Health and productivity is so important. And excuse me, improvements in health of people and the productivity of people can be even a much bigger concern over energy costs for many stakeholders. Post-occupancy evaluation can help you understand what's really happening in your building and not just how it was designed, but what's really happening. When you quantify those things, number 4, it helps inform new policy and hopefully new building codes. And then lastly, because you know, you're an academic, we're academics, I think government and academic partnerships are invaluable so that we can have energy management on a city scale. So with that, I'd like to open it up for discussion and see if you all have any questions. Thank you.
Okay, great. Thank you very much. Thank you. Okay, so we approximately the 10 minutes for Q&As. Yeah, so if you have any question, yeah, please feel free to ask your question to Dr. Cochran. Any questions from the audience? So let me get started with my own questions. Actually, yes, I'm glad to see the NEAT cartridge is still working, and then I also glad to know that you guys upgrade.
Uh-oh. I just have to turn the internet's not working again.
Looks like we might have lost.
Junho, okay, yeah, because I thought it was me again.
I think it might be very challenging.
Junho, interruption. Junho, interruption. Junho.
I think Junho's frozen.
I think
Douglas,
you're frozen
do
and
you
came
have a
back.
question?
I'm not sure. I was hoping you could tell us a little bit more about sort of next steps. What are you going to do now? What are the
So,
next things? And are you linking to other universities? And I'll, on the side, be trying to get Junho back.
Okay, great. So next steps, we've got a couple of next steps happening. In terms of indoor environmental quality, we want to be able to have more robust measurements. And so we're building a robot that will roam around and be able to measure indoor environmental quality and then communicate with the HVAC system to tell it whether it should be warmer or colder or what the conditions are, and communicate with the facility manager faster. From a data analytics point of view, we're still working with the city to help them prioritize what buildings to work on. And so I'm really excited about that relationship, because what we do is we're helping them strategically identify which of their properties they should put out for bid first, so that they can see the fastest ROI in terms of carbon emissions and dollars saved. And so, that's the next step. Some other future initiatives that we would like to do is be able to make it more transparent, because right now, a lot of this data is very academic, but it's not told in a way that the community can understand and really see what's happening and how some of their tax dollars are going to be spent differently and improve their health. So finding new ways of communication to be able to do that. And then, working with our utilities better so that we can have more fluid communication with the utilities, so that we can make strategic decisions together and help them identify better incentives and tax breaks. The utilities already are working with organizations like Home Depot and Lowe's, where if you buy certain things for your home, you already get like automatic deductions for it. So being able to help the utilities know what the right thing is that they should be offering incentives for, so that they can help the most people, and understanding, that low income people and minorities are struggling the most, and trying to just be able to help some of the communities that need it the most.
Okay. All right, Doug, you're on mute.
Am I allowed to ask a follow-up question?
Yeah.
It's actually not a follow-up question. Can I ask a question that completely changes the subject?
Sure.
You hit on a topic or a piece of a topic that is sort of a pet peeve of mine. I encourage my students all the time not to use the word optimize or best, because there's always the clutter of optimize for who or best for who. And the example, you said, if 80% of a group were satisfied, right? The majority were satisfied. And that's a pet peeve of mine, because I always want to come back and say, well, what happens if the 5% that aren't satisfied might be more important? And the example I use is always a hospital. If you have a population, should the patient be the one we optimize comfort for, or the visitors, or the doctor? And quite frankly, your first reaction, well, the patient. And then if I was the patient, I'd really want to make sure the doctor, the surgeon over me with a knife, was optimized to that person's comfort, to her comfort, as opposed to, I don't mind shivering here on the table as long as you're steady. So I just wanted to, I'm sorry to burden you with my standard speech, but I always have trouble with the optimize, best, majority. And I saw you had so many slides about issues related to race, minority, underprivileged. And so when you use majority, you get into that trap. Sorry, that wasn't a question. That was
No,
grandstanding.
it's true. And it is true. And I think that's one of the reasons why, I do say optimize, but that's one of the reasons why I still then try, and I use the word, but I try to say, well, what about the people who aren't comfortable? And so with the one where we were able to get 85% of the people comfortable, what we did was then find ways, how can we make the other 20% comfortable? So our goal was get 80% of the people comfortable with the general HVAC system, and then provide supplemental heating or cooling for the remaining 20%. And so I should have actually talked about that a little bit more. It is important, don't leave out that other 20%, but then the challenge was, how can we make that other 20% comfortable? And so that's one of the things that we were doing. So our goal was hit 80 with the general HVAC system, and then go with supplemental heating and cooling for the remaining 20% so that everyone achieves comfort and you're working to do something for everyone.
Great. I would argue the other way around. I would argue, depending on who the 20% are, who they are specifically, maybe we optimize for them and make them comfortable without any extras because they have been burdened otherwise. So we'll optimize the system to make those 20% happy without extra effort, and the 80% have to do work, special effort, because of other issues, and so it's not the numbers. But thank you, you hit it exactly.
Great. Okay, so Erica, so actually, yeah, sorry, I was dropped off. So
That's fine.
yeah, so my question was, how did you collect the student environmental satisfaction data during the POE study?
So we actually we have 3 versions of surveys for students depending on their age group. So the one that's the high school students use the one like a one that's worded like for adults. And then we changed the wording and made it shorter for middle school students. And then elementary school students, the survey has a lot more pictures in it. And so the one with the elementary school students, instead of using a 7-point Likert scale, we use a 3-point Likert scale, where it's just a happy face, a face with a straight line, and a sad face. And so theirs is a 3-point Likert scale. And then instead of asking them to, with high school students, we give them a list and say, tell me what your priorities are. For elementary school students, we ask them to draw a picture of their space and what they like the best. So we changed the questions. And so we use words differently. So we'll talk about smell and we'll say, instead of acoustics, we'll say sound. So we have altered the questions depending, so we have 3 versions of the questions, depending on the age of the kids. But the younger ones have a lot more pictures in it.
Yeah, I remember that I saw one article published by, I think, a University of Melbourne, the Professor Richard Deere, the POE team. So yeah, they also did some elementary school study, so using some different scale of the survey form. So yeah, it's quite interesting. So actually, yeah, we have one question from the student. Yes, actually, for your information, Aishi is currently working on Carnegie Mellon's NEAT data set with the help of Professor Vivian Lovelace. Okay, Aishi, okay, please.
Hi, I'm Aishwarya. My question is, you mentioned something about the IEQ measurement cart and you've developed something further. Could you just go over it again?
Say that one more time, I'm sorry.
You mentioned something about the IEQ measurement cart and you've developed something further that.
The robot?
Yeah, could you talk about that?
Sure. So what we're doing is making a mobile sensing platform for the NEAT cart. So the current one, you have to push around. Okay. And so you literally have to have someone standing there pushing it. And so now what we're doing is putting it on a remote control so that it can remote, but we're also programming it to be able to roam around the space on its own and be autonomous. So this way, you can kind of send it, you can program in the map of the building and you can send it in so you don't have to stand behind it pushing, and it can just like roam around the space and measure things and then send the data back to you. So even if you weren't in the room, your robot could go in there and look at the space and tell you what's going on.
Okay, nice, thank you.
So it may look like a Roomba, the circle, the cleaner.
It's a tall Roomba. That's exactly what it is. It's just, it's nice. A tall Roomba. So very instead nice. Of sweeping your floor, it's measuring your environmental quality.
Okay, great. Okay, so any other questions? Okay, so if you don't have, let me close it. Yeah, thank you very much for your time, Erica, again. So it is really informative, and I was really glad to see many new update and additional effort from Carnegie Mellon. So we also want to learn for the next opportunity, learn about the current PhD program available in your center. So it'll be a really good format that we want to follow over here. So yeah, thank you again. And then, yeah, let's stay in touch continuously. And then, yes, so yeah, thank you very much again. Yeah, why don't you give him a big hand to her.
Thank you. And if anyone has any additional questions, please shoot me an email
Okay,
or
great.
I'd be happy to talk with you about the research.
Okay, sure.